This is a lesson for Chapter 6, Section 2, Volume of Prisms and Cylinders. And the homework is really going to be taking a look at just cylinders, but we're looking at seeing how the cylinder formula is similar to the prism formula. And here's the volume of a prism formula. It's B, capital B, means the area of the base. And the area of the base can change. See, here this base is a rectangle, 4 by 6. And then we multiply by the height of the prism between the two bases. So here's the other base up top, and the distance between is the height. And so if we take that area of the base, and again that base could be many different shapes. It could have a triangle, a hexagon, octagon, in this case just a rectangle. And so we just multiplied 4 times 6 and then multiplied by the height. And so the cylinder is the same exact formula, except that the base is different. Instead of a rectangle or an octagon or a triangle with actual sides, we have a smooth curve that goes around this shape, which we end up calling a circle. So the area of the circle always has a consistent formula of pi r times, or pi r squared, or r times r. And so for the volume of a cylinder, we can, instead of saying the area of the base, since the base is always the same, we can just say pi r squared times by the height. So we're going to use that formula to help us solve some of these problems. So it says the volume of a cylinder and prism are pretty much the same. We talked about that here, and how the B stands for the area, or area of the base, and the area of the base is always the same for a cylinder. So taking a look at this problem here, we are given the radius, and so I know it's the radius because it goes from this point here, which is considered the center of the circle, to the curve of the circle is 2 inches. So let's start with our volume formula. Volume equals pi r squared times by height. And so we'll substitute some numbers in there. So we'll keep pi as the exact form and just the notation that we use, that Greek letter in the alphabet. And then r is times by 2 squared, and the height is the distance between the two circles, 6. So I'm going to leave this in the exact form to start with. Pi times 4 times 6. I got 4 by multiplying 2 squared. And then 4 times 6 gives me 24 pi. And the units are inches to the 3rd power, cubic inches, because area is inches squared, height is inches, and then when we multiply inches squared times by inches, we have inches to the 1st power. Think of it that way. It would be inches to the 3rd power. So this is the exact answer. If I was to multiply that out, I could grab the calculator here and clear that, and then just do 24 times by 3.14, and that would give me my answer of 75 and 36 hundredths inches to the 3rd power, and that's the approximate answer. So that's what we'll be doing on this next one, except this time they give us the diameter is 6 inches, and so what we want to find is the radius. Well, the radius is always just half of that diameter, so 3 inches, and that's the number we're going to end up using. Along with the height, the distance between the two circles is 2 inches. So let's start with our volume formula. It's pi r squared times height. So pi times the radius, which was 3 squared, and then times by the height, which is 2 inches. So multiplying out those 3's, I end up with 9, and then times by 2, and that makes 18 pi, and this is inches to the 3rd power. So that's the exact answer. Let's go come up with the approximate now. And so we'll punch in 18 times by 3.14 and press the equals button, and I get 56 and 52 hundredths is the approximate answer. And that is inches to the 3rd power. So let's take a look at the next one, and we'll go to the next screen. And it says that a volume, a can has a volume of about 226 and 800 inches cubed, and the height is 8 inches. And so they give us a volume, they give us the height, they want to find the radius. So let's go ahead and write our volume formula, pi r squared times by the height, and let's substitute the numbers that we have. And so in place of the volume, I'm going to put 226 and 800 equals pi, and times by, and let's go ahead and write pi in the approximate form. So I'll change that. So let's write it as 3 and 14 hundredths times by my radius, which is what I'm looking for. So radius squared times by the height, which is 8. So I just took the numbers that I had, was given in the problem, and I substituted those into the formula. And so what I'm going to do first is I'm going to multiply the 3.14 times 8. Let's go ahead and multiply that out. So I'll clear this, and I'll do 3.14 times by 8. And so this equals 25 and 12/100ths. And then rate times by the radius squared equals the 226 and 800ths. Now I'm going to solve for r squared by doing a division problem in opposite operations. I'm going to divide by the 25 and 12/100ths. And so once I do that, now I'm ready to punch these numbers into the calculator. It's 226.08 divided by, and then 25 and 12/100ths equals 9. So 9 equals r squared. But that's not my answer. Remember, that's what the radius squared is. So I still need to take the square root to find out what the radius is. In this case, it is 3 inches. So moving on to the next one, it says the cylinder tank has a volume. So again, they're giving us the volume. Volume is 565 and 2/10 feet to the third power. Its diameter is 12 feet, and they want to find its height. So find the height. So remember, we're given the diameter, but that's not part of the formula. So we want the radius. So the radius is always half of that diameter. So now we've got our numbers that we need. So let's go ahead and plug those into our formula, which is volume equals pi r squared times by the height. So I know what the volume is. It tells me that's 565 and 2/10. And then this all equals the radius squared. So radius squared times pi, put the numbers a little out of order here, times by the height, which was, that's what we're looking for. So it's going to be h. So this time, I'm going to go ahead and multiply that, or square the 6, and I get 36. And then I'm going to change this pi to 3.14, because I'm ready to do some division eventually. And then times by the height, and this all equals 565 and 2/10. So in the calculator, we go ahead and plug in 36 times by 3.14, and that equals 113 and 4/100ths h, and this all equals the 565 and 2/10. So now we're ready to solve by dividing by 113 and 4/100ths. So we'll do the same thing on this side, 113 and 4/100ths. And so now we're ready to do that division. So let's go ahead and set that up. So clear that, and we've got 565.2 divided by 113.04, and this all equals 5. So there's the height, 5, and then whatever our units are, in this case 5 feet. So I'll put in feet right there. So looking at the next problem, it has 2 cylinders stacked on one on top of the other. We're going to find the combined volume. So it doesn't look like there's any holes through it, this thing. So it's just 2 cylinders stacked on one another. And what we're going to do is we're going to find the volume of one cylinder, a volume like the large cylinder. And this time we're combining them, so we're going to find the volume of the small, and we'll add them together. So let's go ahead and set up our formulas. Remember, it's pi r squared times by the height, and we're going to add on another pi r squared times the height. So let's go ahead and substitute our numbers in there. So it's going to be pi times by 3, oops, not 3 for the large cylinder. Let's go ahead and fix that. The large cylinder has 6 as the radius, so 6 squared times by 4. So I'm just getting these numbers here from the large cylinder. And then the small cylinder is pi times 3 squared times by 5. So doing some work there, I get pi times 36 times 4. And then over on this side I have pi times 9 times 5. So 36 times by 4 ends up giving me 144. So pi times 144 plus, and then on this side I have pi times 45. And so now, since I have the same pi value, I can go ahead and add these two together, and that gives me a total of 189 pi. So that's why, again, sometimes I like to leave it in terms of pi if I know I have to add or combine two true terms together and both have a both are being multiplied by a value of pi. So 189 pi inches to the third power, that's the exact answer. Now I can approximate it by taking 189, multiplying it by 3 and 1400ths. Let's go ahead and do that on the calculator now. And so we've got 189 times by, and then 3.14. That's going to give me this number, 593.46. So 593.46, and that is in inches to the third power. And so that's the approximate answer, along with the exact answer right here of 189 pi. So those are types of problems you're going to see on tonight's homework. Good luck.